Alright, it's been a while guys since I've done this, but 3 weeks and I'm back to it, so let's just get straight into it. The 3 rules I want to talk about differentiation are the sum rule, the product rule, and chain rule. And this one's probably easiest, the sum rule. If I've got an expression like 3x squared plus 2x plus 7, and I want to find its derivative, I simply just take bit by bit each derivative one at a time. So for example, this, as we covered earlier, will be bring the 2 down, 6x to the 1, so just 6x. This will become 2 because the 1 gets dragged down, times 2 by 1 is just 2, so 2. And then the 7, well you can imagine that's just x to the 0, so bring the 0 down, becomes 0, goes away, so plus 0. And so our derivative, our dy dx, is 6x plus 2. Awesome. Now this one's a lot harder, but when it looks harder, it's actually much more simple. E to the x, like we covered, its derivative is simply just e to the x, so we leave that alone for e to the x. Sin x we covered becomes positive cosine x. Its negative would rather be, I'll draw the diagram again because MathsJan over here likes it. That's right, I'm filming the same room as MathsJan. Say hi to the camera while I'm writing the diagram.
Hello guys.
Okay,
collaborative.
And then we take the derivative of half, the derivative of half ln x. We covered briefly that ln x is going to derive to 1 over x, so our new derivative will be 1/2 times by 1 over x, which is 1 over 2x. That's the sum rule covered. Moving on to the product rule. Alright, moving on to the product rule. So similar to how the sum rule was for if you had the sum of derivatives, this time it's if you've got a product, so they're times by each other. And it's not as simple as just derive one, derive the other, smush them together. No, not like that. First of all, the rule is the derivative of uv, where u and v are our functions, is going to be the derivative of u times by v plus the derivative of v times by u. So it's kind of like a one, not the other pattern, if that makes sense. And I'll explain how it works. Let's take u to be e to the x, our first function of x, and then v to be root x. And just to clarify, u and v are just kind of a fancy way of saying a function of x and another function of x. We just use u and v because we like letters. Our derivative here is just going to be e to the x. This can be written as x to the half. So using polynomial differentiation, our derivative here will be bring it down, half minus 1 makes it a minus half. So actually this is going to be 1 over 2 root x, which is, hopefully you can see that and make sense of it. It's a bit of a tricky one, but I wanted to expose you guys to it. And so now we do our kind of mishmash formula. So we'll take these two and these two together. So that's going to be e to the x plus, you times them, so it's e to the x over 2 root x plus those two times together, which happens to be the same thing actually. So e to the x times root x. And if you wanted, you can factor out e to the x and simplify, but I'm not going to bother. Moving on now to our second example. This time we've got 3 different products. Why are they so loud? We could just take it part by part and then do it, but I prefer to do it all at once, u, v, and w. So, our u is x squared, our v is sine x, and of course, our w is e to the x. MathsJan, what is the derivative of x squared?
I don't know. No, I'm joking. 2x.
This
yeah,
guy.
I know, guys.
Anyway, sorry, let me stop blocking it. X squared becomes 2x, sin x becomes cos x, e to the x, simple as that. I have to be aware of if I'm blocking or not. Anyway, yeah. So now the rule is take one derivative and 2 functions. That's the general idea of what you want to do here. However many functions you got, you can have a million if you wanted. You take one derivative and all the rest of the functions. So here we will have our first part, which is 2x times by the function, so 2x sine x e to the x. It's a lot of x's. Fortunately, I don't have those. So then we're going to take this derivative Don't look at me like that. We're going to take this derivative times these two functions, which is going to be plus x squared cos x e to the x, and then our final part, which is going to be this derivative, which is the same, times by these two functions, and so it's going to be x squared sine x e to the x, which, like I said, happens to be the same thing as we had earlier. You'll notice I forgot to write something here. It's f prime of x. Oops. There we go. Moving on to the chain rule. Alright, chain rule. This time I'll start with easy and I'll rub it out and I'll do the tricky questions because I want to take my time a little bit on this. So the idea of a chain rule, by the way, quick note, if I say f g of x, I mean f of g of x. So the chain rule works like this. I'm going to take dy dx, the derivative of y, by introducing a new function, u, which I call g, and multiplying it by the derivative of u with respect to x. You can kind of imagine it like I'm saying cancel out the du's. It doesn't technically work like that, but it's the best way I can explain it simply. So dy du, so derivative of y with respect to u, multiplied by the derivative of u with respect to x. And you'll see what I mean. For example, this one here, let's take this part to be our u of x. So u equals 3x squared plus 5, that's 5. There we go. Our derivative of u is going to be, bring that down, so it's 6x, and of course that just goes, that's terrible, that just goes away, so plus 0. Then we take our derivative of the whole thing, so this is now sine of u. Our derivative of that becomes cosine of u. And so now we put it all together. We take this, multiply it by that, and obviously substitute u back in. So it will be cosine of this part, 3x squared plus 5, and multiply it by this, which is 6x. That's our derivative. Bring on the hard question.
Right, so this is a little bit awkward, but I kind of messed up the hard question, and I messed it up so badly that I didn't really have time to film another go at it, and I just kind of had to leave it at that. So, one day I will do a harder question on the chain rule in a short form video, but for now this is all you're going to get. Sorry again it took me so long to get this video out, but I hope you enjoyed it. I decided to throw in some nice funny clips just to kind of, make up for the fact that I've been gone for 3 weeks. Anyway, peace out.